All right, guys, in this video, what we have is a quadratic, right? And what we want to do is graph it over here. And to do so, we're going to find the following. This can help us, and there's also a couple other things that we need to figure out as well. So let's try it here. First off, the direction of opening, we can figure out by our A term. If it's positive, it's going up. Opening up, if it's negative, it's opening down. In this case, we have a positive x squared. You can think of that as 1x squared if you want, which is positive. So this is going to open up. AOS, that's axis of symmetry. Here, our axis of symmetry, we can figure that out by saying x equals a negative b over 2a. That's the formula that we use to find that. In our case, negative 2 is a positive 2. Over 2 times 1 is also 2. So x equals 1 right here. I'm going to draw a dotted line to indicate our axis of symmetry. Down a little bit more. All right, next thing is the vertex. So what we're going to do is, since the vertex is on our axis of symmetry, I'm going to take my x that equals 1. That's where the axis of symmetry is. I'm going to take that and plug it back in to my function. So instead of f of x, I'm going to find f of 1 that I just found and plug 1 in for every x in the equation. So that'd be 1 squared minus 2 times 1 minus 15. And what this gives me is the y value of the vertex. So let's see here. 1 squared is 1, minus 2 minus 15. Okay, well 1 minus 2 is negative 1 minus 15 is a negative 16. And so remember, this is a point. This is an xy point, and my x that I inputted was 1. The output that it gave me was negative 16. All right, and that is my vertex. So at 1 on my axis of symmetry, at 1, negative 16, 5, 10, 15, 16, be right here, way down there on this one. And remember, it's going to open up though, so it's okay. The y-intercept, this is if we input f of 0. But you have to remember, when it's in standard form like this, our a term is going to end up being 0, right? 0 squared, negative 2 times 0. Our b term is also going to be 0. So it's just the c term, which in this case is negative 15. Now notice I put a 0 first, because again, that was the x value I inputted when I did that. So 0, negative 15. 0, negative 15 is really close to this one. And then the little trick with this is that's 1 away from my axis of symmetry, from my dotted line. So 1 away on the other side is also going to be a point on the parabola. Okay, so it's going to open up like that. All right, what else do we have? Do we have a maximum or a minimum? Well, again, if we know it's going to open up like this, again, mine's probably not perfect, but if it's going to open up like that, I missed it. There we go. Then this one is going to have a minimum value, right? It comes down and it has a bottom. So it's going to have a minimum. The value of that minimum is y equals negative 16, the y value of our vertex. Okay. The domain, well, if we take a bigger picture of this, it would go on forever in both directions. So this is from negative infinity to positive infinity. The range, the y values, it's most of them, but it does stop at the y value of negative 16. Okay, and we actually read this from bottom to top. So this is from negative 16 to infinity, bottom to top, all the y values. But since it actually hits negative 16, that's going to get a bracket. The infinities always get parentheses. The hardest part, I think, is whether it's increasing or decreasing. I'm going to use a different marker here to show you. If you read this from left to right, this is going up, starting here, and everything else that way. All right? And so we write this as the x value. So this is the x value of 1 all the way to positive infinity. That's when it's increasing. So we can say from 1 to infinity. Now, one thing to note here is that this gets a parentheses because at exactly 1, it's not increasing or decreasing, it's flat. Okay, so you can kind of read this as it approaches 1. And then same thing, it's decreasing from left, as we read it from left to right, it's going down everywhere from negative infinity on our x values all the way up to 1 again, right? At 1, it stops going down, it turns and goes back up. So it's decreasing from negative infinity to positive 1. Again, both of those get parentheses. That's how you graph a quadratic equation.